So each row you can put it in one curly brackets. So that's the, so how we can mention that many. See here, array size of 4 by 3 to hold integer. 4 by 3 means 4 rows, so 3 columns. See, column 1, column 2, column 3. So this is the entire thing is 1 row, 2 rows, 3 rows, and 4 rows. So each row is having number of columns also in the same. See, this is the one. So this is a 4 by 3. So two-dimensional array. So let's declare that. So and we can use them one by one. So I'll just declare each. So 1 row, and I want three rows. See, I'm just putting all 3 rows. I set it, but I didn't place the values. Let's place the values. So I can just put 1, 3, 4. So in 1, and second same way, second row also 2, 4, sorry, 4, sorry, 2, 4, 3, and then 3, 4, 5. Okay, here something is missing here, integer. So integer array. Same way, so two-dimensional integer array B you can declare. So you do the same thing. So just declare values. So maybe I'll declare. So 1, 2, 3. 1, 2, 3. And 2, 4, 3. And then you can declare 1, 2, 1, 2, 4. So like this, you can declare any values. Okay. Now we need to add these two. So now we need to do, so the result we need to store, right? To store the, so the sum of 2 matrices. So we'll create one more also. So create another array to store the sum of 2 matrix. So int, so see two-dimensional array. You can declare like this, the square brackets you can put the data type after or array name after. It's up to you. So it's not required you have to keep only one side. Both is correct. So 3 by 3. So that is also 3 by 3. That's why I just declared this result also 3 by 3. Now, so let's do the iteration now. Basically, again, 2 for loops. I already told 2 for loops, right? You have to use 2 for loops. So for int I equal to 0, I less than, so I less than array dot length. So a dot length, whatever is a dot length. You can put a dot length, that is 3, and I plus plus. Same way, one more for loop in inner for loop. Int j equal to 0. So j less than so b dot length and j plus plus. J plus plus. So this is the all a dot length and b dot length, I plus plus and j plus plus. So now these two sum. Okay, so you have to assign to this one. So let's assign this to here. C of C of I and j, so is equal to a of I j plus b of I and z. So that's it. So this is the simple. So addition. Same here, use minus for subtraction. Can you do that program? So this the you can take an exercise of that. Can you do that?
Okay.
Yeah. So I'm going to print this. So let's print these values. So I'll print. So inner for loop after you can just put a ln to go back to next row. Okay. So that's why, and I'll print this value directly. Let's print. So println print method I'll use. As I already told you, print method you have to use print in the same row. I z z plus some slash t, some space I'm giving. So that's it. So it will go to next row. Yeah. So call this and see whether these two matrices are printing. Maybe I'll put some separation. Executing the addition of two matrices. So let's call this method static method. That's why I'm calling directly. Okay. So see that? So 2, 4, 6. So you can just see that. So these two, I and j, 2, and so then 3, 2, 5, 4, 3, 7. Same way 2, 2, 4, 4, 4, 8, 3, 3, 6, 3, 1, 4, 4, 2, 6, 5, 4, 9. So this is the same thing. Addition also, subtraction you can do, and same way. And so even multiplication, just do the same thing. So you can do multiplication also. Yeah, that's it. So we don't want to spend much time, but mainly you understand this, how to iterate a two-dimensional array, because your data in the Excel sheets, it will be in the two-dimensional. So as I mentioned like this, right? This is the similar two-dimensional. So please watch this if you have any doubts. So you see how we are accessing the two-dimensional array elements. So this one is very important. It's a ditto of our Excel sheets. That's why we need this concept. Okay. So the last one is some so you need some Java programs now. So what are the Java programs? So we have a not Java programs. I think we did prime number. Sorry, not prime numbers. Fibonacci series. Did we do a Fibonacci series? Armstrong number, Fibonacci series in the beginning. I think we have done.
Yep. We do factorial and Fibonacci.
Armstrong number?
No.
No?
No.
Yeah, that's a very important. Let's do that. Armstrong number and palindrome number. Palindrome number also, did we do? No. palindrome number, I think we have done. Not sure. Did you remember? That's important. If not, let's do that.
Palindrome we didn't do.
Okay. So Java interview programs. So I'll just put like this. Let's do that. So private static void. So check palindrome number. Okay. So you give any number. Okay. You give any number. You need to check that number is a palindrome number or not. So write a program. So write a program to check. So given number is palindrome or not. What is palindrome? So what is mean by palindrome? Anyone have idea?
So the number after reversing it remains the same.
Yeah,
For
exactly. Right.
One, yeah.
So if you reverse the number, it should be same. So even after you, first thing is you need to reverse the number. So you need to reverse the number. Even after reverse, same as initial number. The reversion number, same as initial number. Then that number is called palindrome. So those palindrome, let's see that. So even after reverse, the initial number and reversion number is same, then we call that as palindrome. As palindrome. So this is the palindrome concept. Okay. So now I'll declare some number, some variables. So declare variables. First, I want int sum equal to sum reverse. You take a reverse because you are reversing. So one variable and the remainder is another variable we need and temporary variable. So why I took remainder and temporary variable is, so I'll tell you. First, this n value you assign to this temporary variable because this n value we are going to change. So that's why we need to store in a temporary variable. Store in temp variable. So temp equal to n. Assign the n value to temp. So obviously this will go, whatever the n value, that will go and store in the temporary variable. So why do you need this temporary? You have to compare after reverse. You have to compare, right? The reverse value and this temp value, initially entered value is same or not. If same, you can say it is a palindrome. If not same, you can say simply it's not a palindrome. So let's do that. So first while loop, while n should be greater than 0. That's the first thing. Now you need to extract each digit from the number. How can you extract? So you have to use a remainder. So extract each digit from given number using. So which one you have to use? Percentile. And divided by 2, you do that. So percentile by 10. So n percentile by 10, if you do, you will get a remainder, right? So remainder equal to n percentile by 10. Now it will give you each digit. For example, if the number is, suppose your number is 234, right? So int n equal to 345. First you will get a 3, next you will get a 4, Next you will 5. That's each digit you are extracting with this formula. That's why you need to remember this formula. I'm going to give one more exercise on this. Similar kind of, because that's also asked in the interview. That's why I'm telling all these concepts is important. So you to extract each digit, so you need to do this. We should know this concept. Okay, so fine. Now, so we need to reverse. So to do a reverse equal to reverse multiplied by 10 plus that remainder you add. So this is the concept you need to do that. So then you extract a n value. So n value you change every time, it will change, right? N by 10. You do the n by new n value, you get it. So n by 10. So that's it. So this will do the all the calculations. After this, so if so reverse value is equal to temporary value, then you can say simply so given number is palindrome. So just put that reverse here. Else so given number is not palindrome. So take this. So can you tell me some reverse palindrome numbers?
161.
Anything, right? Anything. See, all single digits are palindrome numbers, right? So, and so 1, 2, 66, 44, 22, 11, all these are palindrome numbers. So you just reverse and you'll get same 1 to 1 only. See, it's a palindrome. So let's give 1, 2, 3. You have to test all combinations, okay? This is all, again, your code is working for each digit or not, you have to check it. Say this is not palindrome. So if you reverse, what you are getting? 3 to 1 you will get. 3 to 1 and 1 to 3 is not same, right? That's why. So it will simply, that means our code is working perfectly. Okay. Next. So we need to write one more program. So given number is Armstrong number or not? Okay, so write a program to check. So given number is Armstrong number or not? What is Armstrong number? So in a given digit, in a given number, you cube the each digit, then sum all the cubes result. Then if you get the same as initial number, then so that is Armstrong number. So you got my point, right? So if you cube the each digit in the, so in a given,
Aisha!
yes. So after you cube each digit, right? You cube each digit. If you get a same as a initial number, right? If you same as the initial number, so then that is We call that Armstrong numbers. So let me show you that exercise, okay? Cube each digit in given number and sum all of them. Get same as the initial number, then that is called Armstrong number. Okay, so this is the Armstrong number means. Suppose you take so 1, 2, 3. So that means 1 cube, right? 1 cube, 125. So I'll take 125. 1 cube plus 2 cube plus 5 cube. So what is this output? Is it giving 1 plus 8 plus 25, 25, 125. 5 cube is 1. It's not coming, right? That means this is not a palindrome, Armstrong numbers. So these are not Armstrong numbers. So you have to find out. So Armstrong number, thing we have one. Let me find out. 3 to 1, 3 cube, 2 cube, 1. No, not that one. Yeah. So anyway, this is the logic. We'll try it. Okay, different one. Even you Google it also, you will get it. So just build the logic. Same as this one only. Okay, same as this one only. First, you extract each digit and cube it. So you extract each digit and cube it. So once you cube them, and then we can. So we can try one by one. Let me. So build the logic first. And protected, static, void, check Armstrong number. So I'll give int n. Declare again first variables. Declare variables. What are the variables we need? Int cube equal to 0. Remainder we need one temporary variable. Same, see, just a variable is changing here, right? Sorry, you have to put comma. So if you're multiple similar data type you are declaring, you have to put a comma, not semicolon. Semicolon means the statement is ended. But here we are, so the same I am applying for this variable and this variable, same data type. Now, so you assign the n value to temporary variable. So while everything similar as the above program. Now, extract the, so the same thing. So everything is same here. And even you get n value also, n by 10. So these two steps are common. Now you need to calculate the cube value. So cube plus and the remaining the remainder value. So you are cubing each digit. So REM, sorry. REM value. Okay, so that's it. Now you just write a logic. If cube value is equal to temporary value, and then you can just so check given number is given number, I can put temporary variable is Armstrong number. That is cube value. Else given number is not So let's Google it or some Armstrong numbers. Okay, you Armstrong numbers. So 153. Okay, you can go to 153. So let me explain 153. So that's 153. 1 cube. So 5 cube. Maybe 3 cube I'll do because already 5 cube we did. See, this is 27 and this is 125. So you got the same, right? So 125 or 25, 152 plus 153. That's one Armstrong number. And still you have a few more. So you can ask Google, it will give you. So all Armstrong numbers. Yeah, here it is. 0, 1, 153, 370, 371, both 401 are the Armstrong numbers. So these you can give all equal to sum of cubes of its digits. Armstrong number is, so let me put this definition there. So it will help you also. Its digits. So Armstrong number is a number that is equal to the sum of cubes of its digits. So that's the Armstrong number means. Let's call this program. So I can give, what is the other one? 370. Let's give 370. See, 370 is Armstrong number. So like this, you can check. So whether a given number is Armstrong number. Same logics. And I want one more program. Sum all the digits of the given number. Can you write that program? Can you take up that? So what you need to do? Sum each digit in a given number. So you need to print the sum of each digit. So here, for example, if you sum 3 plus 4, 7 plus 5, 12. So 12 has to be so output. So that is the program you need to write. Clear? Can you write that program?
Yeah.
So the next one, prime numbers. So this is another important program. So what is a prime number? So prime number in Java is that is greater than 1 and divided by 1 or by itself, right? That's the prime number means. So prime number cannot be, otherwise you can say prime number cannot be divided by the other numbers than itself or 1. So that's the prime number definition. So the example is, you can give the first prime number is 2. 3, 5, 7, 11, 13, 17, 19. So these are the prime numbers. So these prime numbers you need to print. So you need to print, or you need to just check a given number. So if any number they give, that number is a prime or not, you can check it. So how can you check that? 0 and 1 are not prime numbers. 0 and 1 are not prime numbers. The 2 is the even prime number. So because all the even numbers can be divided by 2. So that's why 2 is the even prime number. So you need to check. Maybe you can check one just given number, you check whether that is a prime number or not. Otherwise, you can print. You can print. So all the given numbers are prime or not. Okay. So we'll write a check prime number. That's very important for us. So you can check a prime given number is prime or not. So let's go and do that. I'm going to take some flags also. We can use that flags and we can write that. So this is the important write a program to check. So given number is prime or not. So what is prime number? Let me write a prime number is the number that is greater than 1 and divided by 1 or itself. So that's the prime number. Or prime numbers can't be divided by other numbers. So then itself are 1. So example, you can put 2, 3, 5, 7, 11, 13, 17. So these are the prime numbers. So let's write this. How can you check this? Public static void check prime int n. So you give the any number, that number we need to check. So that number is prime or not. So that's what we need to see that. Basically, you have to divide the given number and then you can check that. But let's see one by one how we can check. So I'm going to divide the given number and I will store in one int variable. Int m equal to so n by 2. So this is the one logic you have to implement first step and then check condition if so n equal to 0. Okay. Or so n equal to 1. Simply you can say that so n is not a prime number. So we can just write because you have to write all conditions, right? So that all conditions we have to include in our logic. So is not a prime number. Else, in case n value is not 0, not 1. So then you can write logic. So what is the logic? So you have to put for so int I equal to 2 and I equal to 2 and I less than or equal to m. So till m I need to iterate this till that n by 2 iterations I have to do. Then I plus plus. So then if n percentile by I is equal to 0, so then n is not a prime number. N is, if it divided by, so I value, that whatever the n value, you can simply say that n is not a prime number. N is not a prime number. So then you can declare one flag variable we can declare. So maybe I can put flag equal to 0, FLA. So that flag I'm putting here 1. Then break it. Flag equal to 1, then break it. So break means this entire for loop will exit basically. If flag means that basically if flag is 0, that is I'm thinking it's a prime number. If flag is 0, so that I'm thinking it's a prime number. So so here I'm checking again. If flag is 0, then I'm assuming that it's a prime number. N is a prime number. That's it. So this is the logic how you can build it. And you give any number, just call this method. Three. Maybe I can call this method multiple times. 5, 4, 9. I can put 13. See? Because same method I'm calling. 3 is a prime number, 5 is a prime number, 4 is not a prime number, 9 is not a prime number, 13 is a prime number. So that's how we can check every number is prime or not. Okay. So that's the so very important program, this one. This one also asked many times in the interview. So one of the other people will keep telling this. This is important. Okay. Any questions before closing? That's all about how to reverse a number means, yeah, I have given on the top. That's the one program, but that I already explained. And yeah, these are the some of the programs. Still, you can refer our blog to get more programs. Next week, we'll start the OOPS concepts. Okay. Whenever you have a time, just let me know. We'll take one session. Okay.